Good morning, guys. Let us get started. I hope you are able to see my screen.
Yes, Karthik.
Yeah. So have you guys gone through the notes that I have shared?
Yes, Karthik.
Yeah. Was it useful?
Yes.
Okay, fine. So likewise, whatever the topics that we discuss, I'll be putting in the form of a question and answers. Like instead of writing the entire story, I wanted to put with the question and answers and then code snippets. So that would be interesting. So like whenever I complete, I will share it again. So request you to please look at it. Okay, now let us,
Yes, Karthik.
yeah, yesterday we have seen the difference between a sleep and wait. Sleep we have completed, but wait we did not complete entirely. We'll see that. But can someone tell me what are the main differences between sleep and wait? Differences
Uh,
between sleep and wait. Yeah, go ahead.
yeah. So within sleep, I mean, like the lock will be there, and with the weight, you don't have the lock. Other, I mean, other thing is like mostly. I'm not getting the word for that.
Sleep method present in the thread class and wait method present in the object class.
Okay. So sleep method can be called with or without synchronized keyword. Wait cannot be called without synchronized. Okay. Now wait is used to for wait, notify all are used for inter-thread communication. So whereas sleep is just making the thread to sleep. So whenever you mention the time in the sleep method, we can guarantee that that is the minimum time the thread will sleep. But wait, if I time mention the time, can I say that after the time it will come back to the execution? No.
No.
Someone has to call the notify. Now today we are going to see. So before we get started to see on wait, notify all, can someone tell me what is the difference between notify and notify all, whatever you know?
Notify means it will notify only one single thread. Notify all means it will notify all the threads which are waiting
Which are waiting on what?
on that object.
Okay. Yeah, fine. Now, in order to demonstrate that, let us see. Now, first, so let us see first notify. Okay. Let us see the notify example. Same code that I'm using. So what I have done is instead of one thread, I have created multiple thread. Let me close all and then open again. So I have a main class, right? So in the main class, so I have taken two ATM threads. So can I say that these two are the ATM threads? ATM and ATM2. These two threads are working on same object. Am I right? Because I passed
Yes.
the same. Okay, now. So I have taken another thread called ABC1. Correct? So ABC1, can I say it is taking a different object?
Yes.
Okay. Now let me set the name to the ABC1 thread. Set name ABC1. Okay. Now I have taken another thread Google Pay and it is working on Karthik account. Now, can you guys tell me net how many threads are working on Karthik account?
Three threads.
Yeah. Let's 07 March class notes. So ATM1, Google Pay. These threads are working on Karthik account. When I say Karthik account, it's an object. Okay. Now ABC1 is a thread which is working on different account called ABC. Correct? Now let us debug this one and see what happens. Let us open the HDFC Bank, Google Pay, ATM. Guys, look at this carefully. We are going to understand what is inter-thread communication, why wait, notify all are present in object class, why not in thread class, and at the same time, what is the difference between notify and notify all. Okay. Now, I'm just starting all the threads. Let me minimize it. ATM.start ATM. So can I say I have started all 4 threads? ATM thread, ATM2 thread, Google Pay thread, ABC1 thread.
Yes.
Yeah. Now first we'll go into the ATM thread. So what ATM thread is working? Which object? Karthik account. Correct?
Karthik account.
Now, so when ATM thread is working on Karthik account, okay, can I say it will acquire the lock?
Yes.
Because withdraw is a synchronized method. Correct?
Yes.
Now, so at the same time, can I, if I try to look at others, it will not come. Correct? Now look at here, account balance is 7,000 and withdrawal amount is 10,000. Sorry, yeah. So withdrawal amount is 10,000. So the condition is true. So can I say that my ATM thread will go into the wait mode?
Yes.
Now when I say ATM thread will go to the wait mode, will it release the lock?
Yes.
Now, okay. Now it releases. So ATM thread went to the wait mode on which object? On Karthik account. Correct?
Karthik account.
That is important here. Now let us debug further. F6. So I'm doing F6, guys. See, the thread has gone into the wait mode. Now let us take ATM2. ATM2 is also working on same Karthik account.
Yes.
Yes. Okay. Sorry, ATM1 or okay, whatever it is, ATM2. Okay. Now here also withdrawal amount is 10,000. I am trying to withdraw. Can I say this thread also will go into the wait mode?
Yes.
And it will also release the lock?
Yes.
Currently, ATM and ATM2 has acquired the lock on Karthik object. And whenever we say wait, then can I say these 2 threads have released the lock?
Yes.
On Karthik account? Yes. It has released. Now let's go to the ABC1. So look at here, ABC1. ABC1 is trying to withdraw, but what is the account for ABC1? It's a different account. It is not a Karthik account, correct?
Yes.
Now, so in order to look at that, if you look at the this keyword, you can see this one, correct? See, ABC is following this one. Okay. Now, can I say if now here also this condition will be true and ABC thread also will go into the wait mode?
Yes.
Okay. But when ABC1 thread is executing, it has acquired the lock, correct? First. Now,
Yes.
lock on which object? On ABC object.
ABC
correct?
object.
And when I say wait, does it has released the lock?
Yes.
Okay. Now, let's go to the Google Pay. Now, I am going to the Google Pay. In the Google Pay thread, I am depositing, correct? So whenever I deposit, I am calling the notify. Okay. Now, Google Pay is working on which object?
Karthik account.
Okay. Now, see here, now how let's carefully understand here. So we have 4 threads, but these 3 threads are working on same object. Okay. Now, on Karthik account, two ATM threads worked, and then 2 went into the wait mode. Correct. Now, when through the Google Pay, whenever I say notify, how many currently in the total example, how many threads went into a wait mode?
2.
In total example.
3.
3, correct? So 2 are with a Karthik account.
Karthik account.
And 1 in ABC. Okay. Now, through Google Pay, you are calling notify. And Google Pay thread is working on which object?
Karthik account.
Okay. So that means now generally people will say that notify will bring all the waiting threads come back to the execution. If that statement is true, can I say all these 3 threads has to come back?
No, only one based on the thread schedule.
As per the statement, all these 3 should come back.
Yes, that is the statement you hear everywhere, correct? So whenever the notify all, I'm talking about, see, we have written notify, but let us talk about notify all. Whenever you say notify all, what does the people will say? Notify all will bring back the execution all the waiting threads. Have you heard that? Am I right?
Yes. Yeah,
Yes.
correct.
So
Yes, sir.
according to that statement, can I say in my example, I have three threads wait into the wait mode. So that statement tells these three threads should come back to the execution, correct?
Correct.
But that is wrong. That is wrong. So whenever you say notify all, so currently Google Pay thread, see which thread is doing the notify all? Google Pay, correct?
Correct.
So Google Pay thread also is working on some object, correct? Which
Yes.
object it
Yes.
is working?
Karthik.
Karthik account.
Karthik.
So what does the notify all will do? So on Google Pay is working on Karthik account. In the Karthik account, earlier how many threads went into a waiting mode? Two. Then it will bring back those threads only. It is so whenever we say that it will bring back to the execution means on that object, because whenever you are working on a threads, can I say thread lock is acquiring on an object only, correct?
Yes.
So here the thing you need to remember is, so notify all will bring back on the particular object how many threads are waiting. All those threads it will bring back. So Google Pay you are calling on Karthik account, right? In the Karthik account earlier there are two threads which are went into the waiting mode. So it will bring back. For example, if I say notify, okay? If I say notify, so then what it will do? On the Karthik account there are two locks, but that went into a waiting mode. So any one of that will come back to the execution. Out of these two, any one will come back. So whenever we say notify all, then other objects it won't consider. From whichever the object you are calling the notify all, corresponding object, what are the 8 threads are there, those will come back. Now let's come back here. Whenever we say notify, now can I say which threads can come back to the execution? You guys tell me.
ATM, ATM2.
Any one of the ATM or ATM2. So can I come back to the ABC1?
No.
No.
Now let's complete this one and see whether ABC1 is coming back to the execution or not. Now let me do F6. So whenever do I say F6, can I say it is completed? Yes. Now I'm going to the ABC1. So do you see the control? It is a light green color. That means there is no control. Now let's go to the ATM2. Do you see the control? No. Let's go to ATM1. Can I say ATM1 started executing?
Yes.
So now let's complete this one. Okay. Now see, does the ATM2 thread is still waiting, correct? And ABC1 is still waiting, correct? Now, so that means whenever we say notify from a Google Pay thread, okay, Google Pay thread is working on Karthik account. So on Karthik account, how many locks were there? How many threads are waiting earlier? Two threads, ATM thread and ATM2 thread. So whenever we say notify, any of one thread which was waiting on that object will come back to the execution. In this scenario, which thread came back? ATM thread, correct? Yeah. Now let us do the notify all. So let us do notify all.
So
now,
after this ATM come back, again ATM2 will also come back?
Yes, whenever we say notify all.
No, only for notify. Only for
notify. No, only one thread will come back to the notify. That second thread which is waiting on the Karthik account will never come back.
Okay.
Unless you call again the notify. So that is that's the reason calling the notify all is the best way than the notify, right? You heard that these things, right? So let's debug this and then you will get to know. Okay. Now ATM thread started executing. I'm going inside. So it has went into the wait mode, done. Release the lock, ATM2 again went wait mode, and ABC thread again it will go into the wait mode, done. So there are many threads which went to the wait mode, like 2 ATM threads. I mean, like 2 threads which are working on Karthik account, another thread which is working on ABC. Now let's call the deposit method. So through the deposit method, you are calling notify all. So Google Pay thread is working on which object now?
Karthik account.
So on Karthik account, how many threads went into the wait mode earlier?
2. ATM1, ATM2.
ATM2, correct? Now, if I say notify all, so on this object, currently, see, look at here. This is the object of Karthik account, right? Now, if you look at here earlier, this one is a ABC account. This is a Karthik account. Do you see the code difference here? Hexadecimal number? Yeah. So now, whenever we say notify all, then which are the threads that were waiting on that particular object will come back to the execution. That means, can I say this Google Pay thread is telling other threads which are waiting on this object to come back to the execution? I repeat my statement. Now, whenever through the Google Pay thread, whenever we say notify all, what it is telling? Can I say it is telling, hey, ATM thread, hey, ATM thread, 2 thread, which you were working on Karthik account and went on to the waiting mode, please come back to the execution, correct?
Yes.
So can I say one thread is trying to talk to other thread?
Yes.
So this is called inter-thread communication. Okay. Now, though these threads are talking to other threads, but how it is identifying, how Google Pay thread is talking to ATM and ATM2 only? Why not ABC one thread?
Based on the object.
Yeah. So that means if you can correlate, right? It is talking to a thread. One thread is talking to another thread. But just like that, it is talking? No. Whichever the locks are happening on the same account, same object, based on that, it is talking. Am I right?
Yes.
Now, let us see notify all. Now, let me do F6. Done. Now, look at here. Now, look at ABC1. Is it executing? No. Look at ATM2. Is it executing? No. Look at here. See, can I say ATM thread started executing? Whenever Google Pay thread started, said notify all. So, Google Pay thread is telling, hey, whichever the threads that are waiting on the Karthik account, please come back to the execution. Then ATM thread said that immediately, yeah, hey, I was waiting, so I'll come back to the execution. So ATM thread started executing. Look at here. Okay. Now if I do F8, so when the ATM thread started executing, can I say it will acquire the lock? Yes. Now after completion of line number 18, it will release the lock because it's a synchronized. So it will release the lock. Done. Now let's look at ATM2. Is it also executing? ATM2 was also having the lock on Karthik account. Is it executing? Yes. So let's see now. It is completed. Now, but look at the ABC one. Is it coming back to the execution? No. So that, but still I call the notify all. Does that mean that it will bring all the threads which are waiting will come back to the execution? No. It will depends on object lock. Which are the threads waiting on that particular object will come back to the execution. Hope it is clear, guys.
Yes.
Yes, correct.
Yeah. So when see, this is very, very important. When someone says that notify all, it does not mean that all the threads will come back to the execution. No. Only the threads which went into a waiting mode on the particular object will come back to the execution. So now, why calling the notify all is better option than the notify option? You understood now? Earlier, I called the only notify. Two ATM and ATM2 threads are there. Only one is executing. When another will come back to the execution, you don't know, correct? So what is the best way?
Notify.
What is the best way? Yeah, correct?
It also depends on use case. In case, let's say we use notify only. So if we know that means so all the threads were not come back. So is there any way to know? Are there any waiting threads from here Google Pay so that we can call more notify so that we can release all?
No, you can check. Them? You can check thread is alive or not. So in the thread class there is alive method is present. You can check is alive is true or not. If the thread is after completion of a run method, thread is dead. So is alive method will return you false at that time. So is alive. So there is a method called is alive in the thread class. Based on that, you can check whichever the thread is alive. Whenever it is alive, that means it is still has to execute. Correct?
Okay.
Yeah. In that way, you can check.
So in Google Pay, when we say notify or notify, so that will execute, right? That will die, I think. It will not.
No, after completion of notify, so like in the Google Pay, you are calling the deposit, correct? So
Okay.
it will call notify all. And then if you complete this 25 line number, the lock will be released. And then whenever you come back, you complete this run method, the end line of run method. Then this
Of
thread is
Google Pay.
considered as state. Yes. This thread is
Okay.
considered as state.
Okay. Now assume in Google Pay we have only notify.
Okay.
In that case, will that Google Pay thread will die or it will still be there?
No. After completion of notify, after completion of execution only. After completion of run method. So you can check that. So here.
So where we have a notify in Google Pay run method?
Just a minute. This is instance method you can call is alive. Okay. Now likewise, after calling the start method, you can check. After completion of the start method, you can check. Okay. Now the notify method is present in the deposit method, not in the run method.
Okay, in
Because
deposit method. Okay.
yeah. So if I have shared the code, right? If you just look at it, you'll understand. Okay. Whenever I do the deposit, I'm doing the notify so that other threads which are waiting will come back to the execution. Now the question is why notify, wait, notify alert in the thread object class? Why not in thread class? Now, can I say that using wait, notify all, these are used for inter-thread communication? Like if it is a sleep method will not release the lock, but wait is releasing the lock. Who is telling that waiting thread to come back to the execution? Another thread, correct? So in the example that we discussed, Google Pay thread is telling all the waiting threads on the Karthik account objects, please come back to the execution, correct?
Yes.
So that means one thread is talking to other thread. This is called as a inter-thread communication. So in order to do the inter-thread communication, wait, notify all are used. Now, why these are present in object class? Why not in thread class? Now, whenever I say that one thread is talking to another thread, just like that, is it talking? So Google Pay thread is talking to ATM and ATM2 and telling that come back to the execution. Why not it is talking to APC one thread?
Different object.
It's another object.
So that means because the lock is happening for this thread, the lock is happening on the different accounts, correct? Or different objects. Now, whenever it is talking to the other thread, it is taking the lock into the consideration. Am I right? So whenever you say object lock or something, you are referring to an object. So if I'm keeping these methods in the thread class, so for all other for every class in Java, object class is a parent class, right? So since I'm talking in terms of object, keeping the methods in the object class making sense. If you keep these methods in the thread class, can it be possible?
No.
Because thread class is not a parent for all the classes, right? All the classes are not extending from a thread class, but all the classes are internally extending from object class. So this wait, notify method, if I keep it in the object class, automatically it will be available for all other classes, correct? Yes, no?
Yes.
Yes.
So that is the reason it makes sense to keep these methods in the object class rather than this one. So I have mentioned this in the notes I'll be giving today. So I have written like with the good wordings. So let me show you quickly. I have not formatted it, but I will do. So what is the difference
Karthik,
between
in the
notify
same
and
in the
notify
same
all?
point, Karthik, this notify, when we say only notify, one of the thread is released. Assume that when we say notify in Google Pay, one of the threads is released. That is ATM is released. Assume and ATM2 is not yet released. Assume.
Yes.
In that case, Google Pay thread still be alive or it will die?
No, it depends on you, right? Whenever you say complete, then it will be die. It depends on you. It will execute completely. It will execute. See, currently, okay, it stopped.
If you write only notify, assume that.
It has after doing the notify. If you complete the run method, it will be considered as state. If you don't complete, it is not. If you run the program, so it will be like whenever I am debugging, it is in my hands. Whenever I run, after completion, after notify, it will complete, right? One by one line.
Okay, it will not wait for other threads to complete. The other threads will be waiting, but this thread will not complete.
Yeah.
This thread
So
will not
whenever-
wait, basically.
Yes.
Okay.
Whichever the threads went into the waiting mode, those will wait. But
Okay, those only will get
Google-
affected.
Yes,
Okay.
yes. So whenever you say notify all,
Hmm.
so immediately from this line, those threads will come back to the execution. No, because it's a synchronized block, correct? So
Okay.
it will say notify all, and then this line, end of the line has to be completed.
Okay.
Then only I can say the lock will be released, correct? On that
So
particular
after
object.
the completion of this complete
Synchronized
synchronized
method.
block, then only they start getting released.
Other threads will come back to the execution
Not
because
immediately after notify all.
yes, because the
Okay,
reason
assume
is,
that after notify all, we have a couple of bunch of statements. So
Yeah.
all those statements has to be completed, basically.
yes,
Okay,
it will be
got it.
completed. It will be
Then-
completed because you entered the synchronized block. There is no one is stopping you until you
Okay.
have a blocking operation.
Yeah, that's fine. But this after the these other waiting threads will not be released immediately after notify all, but after the completion of the synchronized block of a Google thread, basically.
Yes.
Okay, got it. Thanks.
Okay.
Karthik, you mean you're telling that if 25th line, if you write any system that out that println any statement is there after 24th line, so it will execute after
Let's
the
wait. Let me debug it. You will understand. It's a synchronized block, right? You're forgetting the basic principle.
yeah.
Okay. So now let's quickly look at, see, this ATM thread went into the wait mode. It has released the lock. Okay. ATM through went into the wait mode, released the lock. ABC1, yeah, went into the wait mode, released the lock. Google Pay thread. Okay. See, it is executing, notify all. Okay. I did the notify all, but is the synchronized block completed?
No.
No. Let's see. Is it coming back to the execution?
No.
Is it coming back to the execution? No. Why it is not coming back? The basic principle. When one thread, when Google Pay thread is executing deposit synchronized method on Karthik account, it has acquired the lock, though it is calling the notify all, but still lock is present, correct?
Yes.
When the lock is present, can other threads execute any other synchronized method on the same object?
No.
No, that is a basic principle, right? Object lock. Now, if I complete this one, so if I complete 26 line number, can I say the code is like the synchronized lock will be released by Google Pay thread on the Karthik account?
Yes.
So then immediately ATM2 thread or ATM thread, see, it will come back to the execution.
Yes.
So now when ATM thread is executing, can I say it is acquired the lock, Karthik object lock on Karthik account? Yes.
Yes.
So again, 18 line number, if I complete it, it will release. Then ATM thread 2 will come back to the execution, correct?
Yes, sir.
So it's a basic principle of like a lock mechanism, right? But this will never come back because on this lock is happening on ABC1. So no one has notified, none of the other thread has notified the object lock that is happened on the ABC1. So it will be forever in the wait mode. Until the notify
by that
method
time,
is called.
Google Pay thread is dead, and other threads will be executed.
So yes.
Okay.
But this has ABC thread has no relation to the Google Pay thread.
Correct.
Because ABC thread is just doing the withdraw. Okay, and it went to the wait mode.
It is completely isolated
account.
from this
Yes.
notify all.
Yes.
So other object thread.
Yes. Why did I take this ABC thread? Because I just wanted to tell you that the people will have a wrong perception saying that notify will tell all the threads will come back to the execution. No. On a particular object, how many threads were waiting earlier, it will bring back to the execution of those threads only. Okay. Now, so why these are present in the object class? Look at here. Because they are used to control the behavior of threads that are accessing the objects. In Java, threads execute the code in context of an object. Am I right? Because whenever you are executing a synchronized method, the thread will acquire a lock on what? It's an object. Yeah. When a thread accesses an object, it may need to wait for another thread to release the object lock. This is where wait, notify all come into play. Notify all methods allow threads to communicate and synchronize each other when accessing the shared objects. When a thread calls the wait method on an object, it releases the object lock and waits until another thread notifies it, correct? So
Yes,
when thread calls a notify method on an object, it wakes up one of the threads that are waiting on the object's monitor. Monitor is nothing but a log. When a thread calls the notify all method on an object, it wakes up all the threads that are waiting on this one. So since wait, notify all methods are used for control behavior of the threads accessing object, it makes sense to include in the object class rather than the thread class. Hope you understand the answer now.
Yes, sir. But sir,
Yes.
method how only one thread, right? It will call.
I could not understand your question.
Sir, notify method calls only one thread wake up, right?
Yes.
Sir, but how it is identified this particular thread wake up?
No, it is not identified. It's up to the. So now whenever the Google Pay thread says notify, so currently on Karthik account, how many objects are waiting? ATM or ATM2?
Yes.
No, it's up to the scheduler, which will come back to the execution. Scheduler will do that. We
Okay.
cannot tell a particular thread come back to the execution. No, you can, because can you tell at any point of time what thread is executing? No, it all depends on your operating system or scheduler.
Yes, yes.
Okay.
Sir, is there any way to check out what are the threads in the waiting?
So that is what is alive method. You can check it, right? By checking the is alive method, if it is true, the thread is alive. It is not yet completed the run method. If the run method is not completed, then that is alive, right?
I want to know all the threads, sir, which are all waiting.
So
If
I
it is
don't
alive
think we
means
have.
it's only
Sir,
one method, right?
That is based
No,
on
one.
thread priority. We will execute, right? Sir? Maybe. I think.
Yeah, thread priority will be there even after the thread is dead. Okay. So I don't think there is a separate method which will tell you all how many threads are waiting. Let me try. I haven't seen it. If I get it, I'll let you know.
Okay.
Okay. Now let's go into the next topic. So now let's quickly look at. So we have to see what is a. So we have completed. Let's quickly mark it, whatever we completed. Thread, different ways. This one, thread lifecycle, different thread states, need for synchronization, object lock, class lock. So this we need to look at it. I will tell you what is a lock mechanism. Maybe we need to discuss something more. Inter-thread communication, sleep and wait. Okay. Now in the wait mode, so whenever we are discussing a difference between sleep and wait, now can I say that wait is not releasing the lock, sleep is releasing the lock? Is that difference understood for you, all of you?
Yes.
Okay.
Yes.
Now, so when I say, and another first difference is sleep method present in the thread class, wait method is present in object class. Okay. Now the second difference is, so whenever I say sleep followed by sleep method followed by some 1 lakh milliseconds I have given yesterday. When I say 1 lakh or 10,000, it is sleeping for that specified time. Correct?
yes,
Now, but whenever I say wait, there is a method which takes a milliseconds also.
Yes.
Whenever you are using that, can I say after the time, is it coming back to the execution?
no,
No.
give the guarantee.
It all depends on some other thread has to notify it, correct?
Yes,
So that means the difference is, you can say that sleep method will sleep for a particular time. After that, if the system resources are free, it will come back to the execution. And the wait method, we cannot specify how much time it will sleep, correct?
Yes,
It
sir.
will. It all depends on other thread, some other thread to call the notify or notify all.
not fair. Yeah.
So this is the second one.
Yes. Super.
Okay.
And
Now the
so then note wait method, why it has notify with one argument, notify with two arguments we have, right?
so that is what, even if you look at the documentation, it will tell you, you can mention the time. So within the time you can notify also, right? So why it is created? So we need to ask the Java creators. Okay. So the confusion it will create, right? Why like will it come back to the execution after the milliseconds? No. It all depends on notify to be called. Yeah. Okay. Now sleep does not release the lock. Wait will release the lock. Which just now we have seen. Okay. Sleep can be used with or without synchronized block, but wait should be used only within the synchronized block. Now let's see if I remove the synchronization here block. So am I getting any compilation error?
No.
Okay. Now let's debug the code and see. Now I'm just running the code.
Karthik, before going that, the previous point, assume that wait we put 10 seconds approximately, and notify is happened within 1 second. In that case, it will get released, or wait will wait for minimum 10 seconds it will wait.
So
Synchronous block there after complete that one.
So whenever you are running the program, so whenever you notify within the time, it will come back to the execution, I think. And if you are using the milliseconds, I think it will wait and then it will come back to the execution. I haven't tried it, but you can just try with the time.
Okay.
So in the same example, what you guys can do is just put the time. So what I have done, I just had used the wait method. You just give some 10,000, which is nothing but 1 minute 40 seconds, something, correct? And you do the notify within the time and see, whenever you say wait, it will come back to the, after completion of the synchronized block, it will come back immediately. But whenever you give the time, let's just see whether it is sleeping for that time and then coming back. So just look at that. Okay.
Fine. Okay.
Now, so what I have done, I have removed the synchronized block. Okay. And then I ran the program. Whenever you ran the program or debug the program, do you guys see I'm getting some exception, illegal monitor state exception? So now why we are getting this one? The reason for that is whenever you are using a wait mode, can I say that it is releasing the lock? Okay, in order to release the lock, it has to acquire the lock. So how we acquire the lock in Java? Using the synchronized keyword. Am I right?
Yes.
So I repeat my statement. We are getting, whenever I am trying to use the wait method without synchronized block or synchronized method and running the code, I don't get any compilation error, but I'm getting a runtime error saying that java.lang.illegal monitor state exception. Monitor is nothing but a lock. Monitor, see, different words. Like if I say different meanings will be there, right? Meaning of monitor is also a lock. It is telling illegal monitor state exception. That means it is telling you do not have a lock, proper lock. Now, what is the use of a wait method? Wait method will release the lock, correct?
Yes.
So, but it will release the lock means first it has to acquire the lock. Am I right?
Yes.
So how we acquire the lock in Java?
Wherever the synchronized
block, using synchronized keyword as to the method, correct?
Yes.
No, that is the reason so wait should be called within the synchronized block only. I mean, wait, notify all should be called within the synchronized. If you don't call the synchronized, the purpose of the wait, notify all is to talk to each other and release the lock, correct? But
Yes.
since you are not calling without the synchronization, so it will throw you the illegal monitor state exception. So that is what I have mentioned here. Wait can be used only with the synchronized block. If used non-synchronized block, then it will throw the illegal monitor state exception.
Yeah.
Okay. So thread is used to pause the execution of thread for some time. Okay. For example, whenever you are doing some work, you are getting the data. What you are preparing one notepad, and that notepad has to be kept into some location, but that location is not having access, or sometime you need to wait for the location to be accessed. So then what you need to do, you can wake the thread to sleep for some time, because it will not release the lock. After the time, it will come back to the execution.
Okay.
So sleep method will pass the execution of time. Like that means it will hold for some more time. But wait method, yes, wait method also will go into the wait mode, but it all depends on when it will come back to the execution. Some other thread to tell that notify. So this wait notify will be used for inter-thread communication. Sleep method will use for sleep, like pausing the execution for specific amount of time. Okay, if you know the use case, when to notify, when to wait, then go for a wait and notify. But if you just want to wait for some time, I pause the execution for some time, then you can go for a sleep method. Hope you understand the differences now, wait and sleep.
Yes, Karthik.
Yes. Yeah.
So these are very important, guys. I will share the code again today, complete code. I request you guys to please look at it. Okay. So we have completed this one. Now I'll come back to this one, yield method and join method later, because this is a small topic. And first we'll see the multi-threading topic, and then we'll come to this one lock, and then this one. Because whenever I do the multi-threading, and then I will explain what is the disadvantages of synchronization, and then what is the advantages of lock mechanism. Okay. Now, so what is the drawback of a thread? Can you guys tell me?
Once thread is dead, we cannot come back. The thread will not back.
Okay. Any other answers?
We cannot reuse thread.
Yeah. How? How can you say that we cannot reuse?
Because once it is dead, we can't revive it.
So that means whenever I call the start method, and it will execute the run method. After completion of a run method, I cannot call the start method, correct? If I try to call the start method, it is throwing me the illegal thread state exception, right? Because internally it is using one variable called thread status. Okay, if it is a not zero value, it will throw the exception. So that is what we have seen now. So that is a problem with a thread or drawback of a thread. Now, in order to overcome the drawback, we are going for a thread pool concept. So now let us create a package com.ashokit.thread pool. So now in the thread pool, yes, this is very important. Execute an example. Please pay attention. Okay. Now, so the drawback of a thread is whenever the thread is executing the run method, after completion of a run method, if I want to reuse a thread, that means can I call the start method again? No, it will give me the illegal thread state exception. That means I can do the multi-threading, but only by creating multiple thread objects and calling the multiple times the start method. But creation of a thread, multiple, like number of threads will be not a good choice. Like it all depends on your operating system. I will tell you how many number of threads to be created also little later. But so you need to, so whenever you're working with the threads, you need to know, but you have to create some number of threads and then reuse it. So in order to provide that flexibility in Java 1.5, this thread pool has been come into the picture. Before Java 1.5, there is no thread pool. So in Java 1.5, this thread pool came into the picture. So there are 4 thread pools: single thread pool, cached thread pool, scheduled thread pool, new fixed thread pool. So these are the 4 concepts that are available in Java for thread pools. What the single thread pool will tell you, only one thread will be used inside this one. If you are using this one, only one thread will be created, and that thread will complete the entire work. Whenever I say fixed thread pool, you will tell, say, for example, I have 1 million records. I cannot create just like the threads. What I will do, I will, based on my CPU configuration and all, I will calculate how many number of threads to be created. There is some formula. I have mentioned that in the notes. I will tell you that also. So this is a formula to create a number of threads. Yeah. So processor count multiplied by desired thread CPU pool utilization and overhead thread count. I have provided the explanation as well. I'll come to this later. So how many number of threads to be created? You have a formula to calculate. For example, based on the formula, you calculated around 4 threads. Now you have 1 million records. In order to access, if you are processing this 1 million records with a single thread, it takes some time, but you want to reduce the time. At the same time, you don't want to create multiple threads, because if you're creating more threads, then you have to increase your like hardware of your laptop or computer. Hardware in the sense like currently my RAM is 2 GB RAM. I have to go for 4 GB or 5 GB or 10 GB. And I have to change my, currently mine is i5 processor. I have to change it to i8 or i10 processor. So i10 processor will have more cores than the i5 processor. So increasing the number of threads depends on your hardware. So if you are increasing the hardware, then you have to put money, right? So that's the reason whenever you're creating a number of threads, you need to be cautious. So now in the fixed thread pool, what I will say, I will provide, I want to use only 4 threads. So that 4 threads will make, look at the entire 1 million records and it will complete the work. So that means in the fixed thread pool, the number of threads are fixed. Okay. In the cached thread pool. So in the cached thread pool, you don't need to tell anything. Okay. How many threads to use? Scheduler will start with 1 thread. If the thread is busy, it will create another thread. If now 2 threads are there. If the 2 are busy, then it will create 3rd thread. If 3 are busy, it will create 1 more thread. That means whether to create a new thread or not, that decision will be taken care by the operating system. Okay, you don't need to worry about it. But if, for example, if there are 4 threads have been created, but out of that 1 thread is free, then it will reuse the thread. If all the threads are busy, it will create a new one. If any of the thread is free, then it will reuse it. So that means you don't need to tell anything that you have to create particular thread pool or particular thread or not and all. You don't need to tell anything in the cached thread pool. So the decision is taken care by the operating system. Now in the scheduled thread pool, it is nothing but a fixed thread pool, but you can provide some delay. I just wanted to execute after 1 hour, after something. So scheduled thread pool is nothing but a fixed thread pool, one type of a fixed thread pool, but you can provide some delay. So these are the thread pools that are available in Java from 1.5 onwards. Now it's for concept wise, everything is good. Now the question comes, sir, how can I create this thread pool? So for example, for time being, let us start with a fixed thread pool. I want to create a fixed thread pool of 3 threads. How can I create? That's where the executor framework. Have you guys heard executor framework? Name?
Yes, we heard.
Others? What about you guys? Others?
Yes, Karthik.
Yeah. So whenever we say thread executor framework is used to configure the thread pool. Now, as part of the executor framework, there are some classes. Now let me open one class called executors. Are you guys able to see one class called executors? You can see C. C means class, I means interface. Executors, it is present in java.util.concurrent. So this java.util.concurrent package is introduced in Java 1.5. Now, if you open this one, so this is a class. Now, let's look at all the methods. In order to see all the methods, do Control O. Do you guys see some method called as new fixed thread pool?
Yes, we are seeing.
Yeah. So if you look at here, new fixed thread pool, can I say this is the method? Now, this is the method which is responsible to create a fixed thread pool. What does this method is taking? It is taking n threads, one integer argument. That means that integer argument is nothing but how many threads you want to create. So now, and what kind of a method is this?
Fixed
Static method.
Static method.
Yeah. How can we call the static method?
Class
By
name.
name.
Okay. So by the class name, correct? What is the class name here? Executor. Now, if I want to create a fixed thread pool, how can I do? Executors
dot new fixed
thread pool 3.
Thread.
Okay. Now, what this executor
executor service is returning.
Yeah, just wait. Let me complete. So the new fixed thread pool is returning. What it is returning? It is returning an executor service object. What is an executor service? Executor service in it is an interface. Okay. Now copy this. It is returning the reference of an executor service. Now executor service EX. So this is how you need to create a thread pool. Now, whenever I create a thread pool, whenever I create a thread object, after creating a thread object, I'm calling the start method. Then only the thread will create an independent path of execution. Am I right?
Yes, sir.
Yes, sir.
Yeah. Now the thing is, now I created, say, with this line of statement, I can say that I don't want to create a general thread. I want to create a fixed thread pool of 3 threads. Okay, only 3 threads. Neither it will increase nor it will decrease. Okay, only I want to use 3 threads to the entire process. Done. Now, whenever we say thread is nothing but an independent path of execution. Now, if I am extending a thread class or implementing a runnable interface, I will create an object by calling the thread class constructor. But do you have anything like this here? No. So now, and after that, I am calling the start method to create an independent path. Now, how can you create an independent path of execution whenever you're using a thread pool? Or how can you trigger a thread? Then in the executor service, there are different methods: execute or submit. So do you guys see submit method?
Yes.
Okay. Submit method, which is taking callable reference, submit method, which is taking runnable reference, correct?
Yes.
So I have to call the submit method or execute method. So there are different methods called, see, there is one method called execute, which is taking a runnable reference. That means it is taking a runnable reference means what? I have to create a class, implement the runnable interface, override the run method. In the run method, you write whatever the thread execution you want to write, you do that. Okay. Or this is one way, or ex.submit. So whenever you are using you can use the execute method, you can use the submit method. I'll come to the difference between these two little later. So if I'm using a submit method, I can pass the callable reference also or runnable reference also. Okay. Now, whenever I'm using a executor framework, which methods are responsible to create an independent path of execution is nothing but execute method or submit method. So whenever I say execute method, it will create an independent path of execution. And that independent path of execution should start the execution from a run method. Now this execute method is taking a runnable reference. So what are we going to do tomorrow is, so we are going to implement the multi-threading program using this executor framework. Does it make sense?
Yes, sir.
Yes.
Yeah. So tomorrow will be very important class. I'm going to tell you how to implement a multi-threading. When I say whoever is not speaking, please go on mute. Yeah. So tomorrow I'm going to tell you the multi-threading program with an example. And what is the homework for you guys is, can you guys identify what is the use case in your project that you can do a multi-threading? For example, you might be working on banking, you might be working on insurance or life sciences, or you have some domain, right? Are you guys working, all of you?
Yes, sir.
Yes, sir.
Yeah. So the work for you guys is to identify where can I implement a multi-threading scenario. Because I cannot see, there are around 50 people. I cannot ask you guys, tell your project and I can tell you, right? Now, since you are working, don't you know your project functionality? Correct?
Yes, we know.
Yeah. So you identify what is the use case, you can write the multi-threading. So then whenever I will take one example and I will explain how multi-threading can be implemented. Then I will tell you, if you want to write this example for your project, what all the changes you need to do. Only some minimal changes you need to do. What are those things you need to do, that I will explain, so that you can practice or you can convert this multi-threading example into your project. Okay. For example, there are some people who does not know how to they are not able to figure it out whether they can apply the multi-threading scenario or not. Then what those can do is, whatever the example I am telling, you concentrate on that, and if in the interview that is asked, then you can tell that this is the example that you implemented. Okay.
Okay. Mainly we are using the parallel processing, right?
So not parallel processing, Satish. It's a multi-threading. I will tell you. Just wait. Okay. Any questions? Will you guys be finding it out by tomorrow morning?
Yes, Karthik.
Yeah.
So Karthik, in my project, they are using futures and all. So
Yeah,
is
that
it
is
a
also
part of multi-threading?
yes. So wherever they are using a feature, just look at, they might be using the thread pool as well.
Yeah.
It
I
is
mean,
not.
they.
Yeah. So wherever they are using a thread pool, what you can do, what you can do in your project, go executors, see, there can happen that the people are projects are already using a multi-threading, or they are not using, but there is a scope you can add your code, correct? So identify that scenario. For example, if mine is a insurance project. So in the insurance project, typically what happens? Every day, there are some people who are yet to pay the premium, correct? So I have to send a reminder message or email to them. So what I can do, so that number of people will be in a bulk, right? Maybe in millions or some thousands or 2,000 or something. So what I have to do, can I say that is one area where I can do the multi-threading to trigger the messages instead of triggering the message from the application? Can I say that is one example? Yes. Now for those if your project is very big, they might have implemented. Then copy these executors and go to search, go to file, and then select star.java and click on search. It will give you all the files wherever this executor service is used. And after that executor service, you can see whether are you guys using the fixed thread pool, cached thread pool, scheduled thread pool or not. If you are using, and what is that use case, that you can find out. And once I explain the code, you can relate that code to your project so that you can answer very well in the interview.
So in that case, in your case, you will be using thread pools along with the observer pattern, right, to send notifications.
So observer, yeah. So we can do, but again, the whoever is attending here, they might not know what is an observer pattern, correct?
Correct.
So again, that's a problem. So I will be taking plain example of how to implement the multi-threading only. Okay. I don't what you call complicate by explaining the observer pattern, because for the threads people, like whoever is attending the thread class, they don't mind about the patterns, right? They want to know the multi-threading, how it can be implemented, correct? So what you can do, you can club this and with that so that you can explain a better scenario.
No, I'm just asking, in your project, you are saying you are using thread pools for sending notifications. I'm asking, are you using observable pattern along with the thread pools? I'm asking that.
Yes, that might be the possibility. Yes. Okay. Yeah. So that is a work for you guys. So please come back tomorrow and please be on time, like exactly 6 a.m. or 6:02. Tomorrow will be interesting. We will continue. Okay. Thank you guys. Thanks for joining. Have a nice day.